All right, we're going to keep going with our work with compound probability. And this particular video will be looking at mutually exclusive events and the probability of A or B happening. And we'll start with an introduction and then do a couple examples. All right, so the definition of mutually exclusive events. Events A and B, whatever those events might be, again, they might be flipping coins, drawing cards, or something out in the real world, are mutually exclusive if the probability of both of them is 0. Okay, so probability of A and B is 0, meaning they both cannot happen at the same time or in sequence. Okay? They both cannot happen at once. The probability of both of them happening is 0. Okay, so we'll look at some examples, but, well, actually, let me give you an example right now. I draw one card out of a deck. Okay, event A is getting a king, and event B is getting a 5. Unless someone is totally cheating with this deck of cards, the probability of getting a king and a 5 on the same card, probability of that is 0. So those are mutually exclusive events. A and B are mutually exclusive. All right, a quick reminder about adding fractions, because we'll be doing that a little bit in this topic. Let's say we have 3/7 plus 5/8. All right, we need to get common denominators. You do not do this. You don't do adding across the top and adding across the bottom. No, don't do it. Not allowed, okay? But what we can do is get some common denominators. And remember the rule, you can always multiply any individual piece of any equation by any special version of 1, and you don't have to do it to both sides. You don't have to do it to all of one side or all of the other side. You can do it piece by piece. As long as you multiply by special versions of 1, the values don't change. So let's multiply across the top and across the bottom. We get 24 out of 56 and plus 35 out of 56. Okay, so now that we have common denominators, our answer will be out of 56. And I get 59 out of 56, which is 1 3/56. I honestly kind of like the improper fraction a little bit better. The mixed fraction is a totally correct answer as well. Do whatever your teacher asks of you on this guy, okay, in terms of how you express your final fraction. Let me see if I can come up with another one here. Let's say we have 4/12 plus 5/18. Okay, so in this case, we could, here's what we could do: multiply by 18 over 18, multiply by 12 over 12, guaranteed to get common denominators. Let's be a little bit more efficient though here. I'll erase that away. Let's think about what the least common denominator is here, or the least common multiple. And it's going to be 36. 12 and 18 both go into 36, and 36 is the smallest number that works with. So we can multiply this by 3 over 3 to get 36 on the bottom, and 2 over 2 to get 36 on the bottom as well. Okay, and once we do that, we'll get 12 out of 36 for the first one, and 10 out of 36 for the second one, and we get 22 out of 36 overall. And we can simplify that down, and we get 11 over 18. Okay, so there's my final answer there. Just a quick reminder on adding fractions. So here's my rule: probability of A or B. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of them both happening. Okay? So or, I often say in probability, or means add. Okay? So if you see an or, in many cases we're adding. Not guaranteed, not always, but in many cases we are. But then why do we subtract this off? Okay, so this piece is what I call the overlap, or it's what was double counted. Okay, there might be something that showed up in A and also showed up in B, and we counted it twice. So let's subtract one of them away so we're not double counting something. And we'll look at an example for that as well. Okay, but that's our formula right there. Let me get rid of some of this notation around it so you can kind of have the formula clear by itself. Okay, so that's our formula right there. Probability of A or B is the probability of A plus the probability of B minus the probability of both. So let's get started with some examples. You're drawing one card from a deck. So notice we're just doing one card right now. Okay, and we're curious, what's the chance it's an ace or a 4? I don't care about any of the other cards. I don't care about suit. So the probability of ace is 1 out of 13. The probability of 4 is 1 out of 13. And we have to subtract off the probability of both. So what's the chance of getting both an ace and a 4 in one card? It's 0. So our final answers, we have common denominators already. Final answer is 2 out of 13. And that kind of makes sense. Ace and 4 are 2 of the 13 ranks. Okay, so there's 2 out of 13 chance of getting an ace or a 4. And I hope you noticed we should just subtract it off a 0. So maybe you're thinking, why do we even need that subtraction, right? Let's draw one card from a deck. Probability of ace or a heart. Okay, is it possible to get an ace and a heart at the same time? It is. It's called the ace of hearts. Okay, so let's do it. So probability of an ace is 1 out of 13. Probability of a heart is 1 out of 4. And how many cards are both the ace and the hearts? It's 1 out of 52. There's only one ace of hearts in the deck. Okay, so let's do the math now, and we'll need to get common denominators. Everything's going to be out of 52. There are 4 out of 52 aces, 13 out of 52 hearts, minus 1 out of 52. Are you seeing that the ace of hearts showed up there? The ace of hearts also showed up there. So let's subtract one of those guys away. Okay, and we are going to get 16 out of 52, which is dividing by 4 out of 13. Okay, so there's a 4 out of 13 chance of getting an ace or a heart. All right, next one. Roll a dice once. What's the chance of getting a less than 3 or an odd? So let me show you another way that I like of doing OR probability with kind of a simple setup like this. We're just rolling one die once. Let's highlight in green the numbers that work to get in terms of a success. Less than 3, those two numbers are less than 3. And additionally, let's highlight some odds right there. And so these are the two numbers that don't work. The 4 and the 6 don't work. Okay, so how many ways do we have of getting a success? We have 4. How many total things could happen? 6. So our chance is 2/3. Keep in mind that said less than 3. It didn't say less than or equal to 3. Okay, but that wouldn't have mattered because 3 showed up in the odds anyway. So regardless, the 3 was a success. All right, rolling 2 dice. What's the chance of getting a 4 on the first die or a sum of 7? Okay, one of the most handy things you can have in a probability class is a dice chart. You can always just draw one quickly up on your own, or you could print one out or find one online. Okay, let's say that this is the first die, it doesn't really matter. And let's say that this is the second die. Okay, so I'm going to highlight let's try to color coordinate here. On the first die, we're getting reds, so let's highlight in red. A 4 on the first die. So these are my successes. Okay, or a sum of 7, and I'm going to do those guys in purple here. So how many sums of 7 are there? Actually, before I do that, 4 on the first die, there are 6 ways that could happen. Sum of a 7, I'll do in purple. There are 6 ways that could happen, okay? And how many ways are there that both could happen? There's one way that both could happen. Okay, this is out of 36 total. This is a 6 by 6 grid. Okay, so there's 6 ways out of 36 we could get a 4 on the first die. 6 ways out of 36 we could get a sum of 7 minus 1 that we just double counted. And we're going to get an 11 out of 36 overall. By the way, this dice table is, I think, really interesting to me. It really helps you in your Monopoly game, by the way. Hope you know that 7 is the most popular, or not the most popular, the most common sum to roll when you're rolling 2 dice. There's 6 ways of getting a 7, and contrast that with getting a 2 or a 12. That's why those guys are very unlikely, because there are so many fewer ways of getting those results. All right, that's a good place to stop right there.